Let's calculate the galaxy motion in redshift z values. The galaxy we're going to look at is a very nearby galaxy, M31, known as Andromeda. Andromeda is the very large galaxy in the center of the image. This small galaxy on the bottom right is a dwarf elliptical that's orbiting this large galaxy, M31 Andromeda. Now we're given an H alpha line, and it's observed in one of the spiral arms coming towards us from this particular galaxy. The spiral arms rotate towards and away from us, and the one line that we are observing in the spiral arm is H alpha, and we observe it at 6556.2 angstroms. The wavelength of H alpha measured in the laboratory is 6562.8 angstroms. We want to find the Z value for Andromeda, which is called the redshift value, and then we want to find the velocity of M31 in units of kilometers per second. So let's go take a look at our equations. Our redshift value is equal to delta lambda over lambda, which is equal to the radial velocity divided by the speed of light. In this case, delta lambda over lambda is equal to the observed wavelength minus the wavelength measured in the laboratory. So let's go take a look at what we need to solve. We're solving A first. We're looking for Z. Z is equal to delta lambda over lambda, which is the observed wavelength minus the laboratory wavelength divided by the laboratory wavelength. So we're giving an observed value at 6556.2. Notice the word observed here, so it tells you that. 6556.2. So we'll substitute that in. And the units are angstroms. Angstroms have a little a with a little 0 at the top. So we're subtracting off the laboratory wavelength, which is 6562.8. Same units, angstroms. And once again, it is divided by the laboratory wavelength, which is 6562.8. Once again, the units are angstroms. Now let's take a look at what we can eliminate in this equation. All of the values have the same units of angstroms, so we can divide the angstrom letters out. Now we're just left with numbers. So we want to take 6556.2 and subtract off 6562.8. So let's get out our calculator. 6556, I just went to Google and typed in calculator in the search engine, and I pull up the calculator, and we want to type in 6556.2, and we want to subtract off 6562.8. 6562.8, and we hit the equal sign, and we get a value. We want to divide that by 6562.8. 6562.8 equals, and we get 0.0010056 and all these other numbers. The 6 is higher than a 5, so it would kick this number up to a 6, which would kick this 0 up to a 1. So it would be negative 0.00100 or 01. So let's put that in. So it's negative 0.001. We'll just keep it to that. 001. 001. Even though we have 1, 2, 3, 4, 5 values here, if we stuck in the other ones, we have 5 values, we'd put in a 01 in here. But we can round it up for our simple calculation to be minus 0.001. And that is our redshift value, Z. So I'll put a box around it. Now, the second thing we want to calculate is what's called the velocity. So in our Z equation, which is equal to VR over C, which is equal to delta lambda over lambda, we have this V, which is the radial velocity, or the velocity of the object either moving towards us or away from us, divided by the speed of light. We already know the Z value, so it's minus 0.001. You can put the other ones in there, 01. And that's going to be equal to our V radial divided by the speed of light, by this equation right here. All we need to do is substitute in for the speed of light, which is about equal to 3 times 10 to the 8th meters per second, or 10 to the 5th kilometers per second. And since we know we want units of kilometers per second, I'll put the speed of light in terms of kilometers per second. Carry our Z value down, 0.00101. And now all I need to do is multiply both sides of the equation by this 3 times 10 to the 5th. 3 times 10 to the 5th kilometers per second. And then I can cancel out units and letters and numbers. 3 times 10 to the 5th on the left-hand side, kilometers per second. So let's go ahead and cancel out units. We got a kilometer per second here, kilometer per second on the right-hand side. 3 times 10 to the 5th cancels with 3 times 10 to the 5th. And we are just left with a V radial on the right-hand side. And that's going to equal 3 times 10 to the 5th multiplied by our Z value. So we go back to our equation. We already have our Z value entered into there. So now we hit multiply 3e5. And we're going to get minus 301.7. And so let's put that in there, minus 301.7. And we have to keep our same units, kilometers per second. And that is going to be our radial velocity. Now what we have here is the speed of the galaxy. The galaxy is moving towards us or away from us at a value of 301.7. Now because we have a negative number, the negative number indicates a blue shift. A blue shift is telling us that the galaxy is moving towards us. So in this particular case, the Andromeda galaxy is moving towards us, or the Milky Way galaxy, at a speed of 301.7 kilometers per second, as V radial is less than 0. So we have a blue shift because V radial is less than 0. And the speed of Andromeda is 301.7 kilometers per second towards us. And that's how you calculate the galaxy motion in Redshift.